So we will start with the experiment called as implementation of full adder. So let me give its write up. Okay, so I'm opening the write up just. So yeah, so this is experiment number 6, right? Which I have uploaded on the classroom. And the name of the experiment is design and implementation of full adder circuit, right, using basic and universal gates, right? So here I will be covering implementation using basic gates, right? I am expecting that you should implement it by using universal gates, right? So basically there are two universal gates. One of them is NAND and another is NOR. Okay, so yes, so the aim is to design a full adder circuit, right? So in theory, right, we have seen in theory. Let us go to the theory, right? So first of all, let me give a glimpse that what we have seen in the theory. So basically, what is full adder? Full adder is nothing but when we add three binary bits, right? So that is your full adder. Okay, for example, 0 plus 0 plus 0, we can see that sum is 0 and carry 0, right? So this we have seen in the lecture. Similarly, 0 plus 0 plus 1, so I can say that sum is 1 and carry is 0. Similarly, 1 plus 1 is 1 0. If you are adding plus 1, it will be 1 1. That is sum is 1, carry is 1, right? That is what I am trying to say, is that 1 plus 1 plus 1 is nothing but sum is 1 and carry is 1. Okay, so here in all the cases, what I am doing, I have given here three cases. So in all the three cases, I am adding three binary bits, right? So these three binary bits are called as your the circuit which will perform this operation is called as your full adder. Okay, so depending on how many possible combinations will be there. So if we are having three bits, right? So this table we have seen in the lecture, that if we are having three bits, then we can have eight possible combinations, right? 0 0 0 0 0 1 and like that. Okay, so last combination is 1 1 1. So we know that 0 plus 0 plus 0, we know sum is 0 and carry is 0. Similarly, 0 plus 0 plus 1, this is sum is 1 and carry is 0. Okay, similarly, 0 plus 1 plus 0 is sum is 1 and carry is 0. Okay, so like that way, 0 plus 1 plus 1, sum is 0 and carry is 1. Okay, so similarly, what I have done, I have added three digits and I have written what is the sum and what is the carry. Okay, and then we can of course represent by using the decimal number system from 0 to 7. Okay, and if we want the product form, okay, if you want the product form, you can just see here that this is the product forms. Okay, so these product forms, these are nothing but your, just one second. Okay, so these are nothing but your product terms, right? Product terms which are represented by small m. Okay, now if we consider, if you want to have the circuit for carry, so what we can do is, or let us suppose that yes, we want a circuit for carry. So here one is present, here one is present, here one is present, and one is present, right? So if you see corresponding 3, then 5 and 6 and 7, right? So this 3 4 3 5 6 and 7, right? So these are nothing but the decimal numbers, right? Where we are getting 1, okay, at the carry place. Okay, now what are the product terms here? So here the product terms, we can say that this is one of the product term, second, third, and fourth. Okay, now if you want to have the carry expression, we can have the carry expression like, we will take the product terms, that is a bar b c, right? A b bar c, a b c bar, and a b c, right? And then by using boolean expression, you can simplify it. Okay, but we have a very good method, we have seen it today, that we can simplify it by using the k-map expression, right? So in k-map, we know how to number the cells, right? So this is 0, this is 1, this is 2 3 4 5 and 6 and 7, right? So how, where to write 1? So this is your 0 1 2 3 5 6 7, right? So I've written here 3 6 7 and 5. Okay, and then we can group the numbers, right? As we have seen in the lecture, in K-map we can group the numbers and then we can write the expressions, right? So I'm just changing the colors to group the numbers, and then this is another group, and third group is here, right? So we can write the expression like, if we are grouping these two numbers, what is common here? One is common, means what? A and
AB.
B is common, right? So this is your AB. Similarly, if I'm grouping this number, right? So this will be, you can say, BC. And if you are grouping these two numbers, right, here what is common? BC is common, and from here A is common, right? So instead of writing this big expression, right, I can write a very simple expression, and then this simple expression I can realize by using some gates, right? So that also we have seen in the lecture, that yes, if I want to implement AB plus BC plus AC, then I want for AB one AND gate, for BC another AND gate, for AC and third AND gate, right? So three AND gates, right, I want, and at the output I'm getting AB, I'm getting BC, and I'm getting AC. Okay, now if I want to add AB and BC, right, then I, for addition, I need OR gate. So I'm using here OR gate with green color, you can see. So at the output of green color, I'm getting AB plus BC, and then this term AB plus BC is added with AC. So that's why I want one more OR gate. So that is blue in color. So again, I'm using this OR gate, and I'm getting the final output of carry, that is AB plus BC plus AC. Okay. So this is how we are dealing with the carry term. And then sum term, again, we have seen in the lecture that yes, for sum term, again, what is present is, we can say that this is present. Okay, I will just take the highlighter, and yes, for some term, here one is present, here one is present, here one is present, and here one is present, right? So at what times one is present? At one is present, at two one is present, then four पे है, उसके बाद में फिर seven पे, right? So again, what I will do, I will just try to simplify by using this. I'm trying to simplify by using this K map. Okay, and here if I try to place one, so one is here, then one is here, then one is here, and finally one is here. Okay, so this ones we cannot combine, so that's why we are directly taking the product terms. Okay, we cannot simplify this, we cannot combine this ones, because these are diagonally, we cannot combine it, and it is not in any rule. So that's why for some terms I am directly taking whatever product terms which are available, which I have written. Okay, so this terms, right, this product terms which are coming from, maybe you can say, where 1, 2, 4, and 7, right? So corresponding product terms have, I'm having the corresponding product terms, and then I'm adding the product terms, right? So this is your sum of product form. So we can say that from this two we can obviously take a bar common, and again from this two we can take a common, and then yes, we know that this is expression for XOR gate, so B XOR C, and this is expression for XNOR gate, so B XNOR C. And if I replace B XOR C with some term D, right, for simplicity purpose, this will be A bar into D plus A into D bar. But yes, we know that A bar D plus A D bar is nothing but, again, it is the expression for your XOR gate, so it will be A XOR D, and I'm replacing the original value of D, that is B XOR C. So what is the finally expression for sum? Finally, the expression for sum is very simple, and it is A XOR B XOR C. So for how I can implement this thing, so again, there is a very simple thing, that I want one XOR gate, I want one XOR gate, right? And if I'm giving from here A, and if I'm giving from here B, at the output I will get A XOR B. Okay, now if I want to add one more C in this A XOR B, so I will have to give the another input of second XOR gate as C, and output will be A XOR B from the above this point, and from here it will be XORed with C. So this is nothing but your sum. Okay, so this I can say this is the circuit of your full adder. Okay, so this is full adder circuit. We can implement this circuit by using three AND gates, two OR gates, and two XOR gates. Okay, so this is the thing which I will show you how to implement. Okay, by using two adders also we can implement a full adder circuit, as well as one more thing we can
Sir, you are not
implement by
audible.
using. Hello, am I audible?
Yes,
Yes,
sir.
sir, you
Yes.
are.
Yes, sir, you are
Okay,
audible.
You are
okay,
audible, sir.
kindly check your mic. Okay, yeah. So kindly check your headphones or speakers, okay? Because I think I'm almost very well connected. Okay. Yeah, so I can see my voice level and it is up to the mark. Yes. So this is I was saying that yes, this is your full adder circuit, and what I'm expecting from you is that you can have the same results, right? But only by using the universal gates. Okay, so you can try it at home by using universal gates. Now, very important point is that how to implement this on Tinkercad. Okay, how to implement this circuit on Tinkercad. So what I will do, I will just start my Tinkercad. Okay, so I have started the Tinkercad account, and yes, it's already logged in. Okay, so I will go to the circuits and I will try to create a new circuit. Okay, now yes. So one basic thing, okay, one basic thing. You know, if I want, if I want टू कनेक्ट एलईडी, एक बार फिर से रिवीजन देता हूं मैं आपको. एलईडी अगर कनेक्ट करना है तो कैन आई से यू नो दिस, थोड़ा थिक करता हूं. ओके, एंड आई विल यूज रेड कलर. ओके, सो कैन आई से this is symbol for what?
Your screen is not visible.
Screen is not visible.
Visible.
Visible, sir.
Yeah,
Sir,
visible,
it's
sir.
It is
visible.
Kindly
visible.
check. Kindly.
Visible.
Yeah. So yes. So this is the diagram of LED, right? If you have any difficulty, put in a chat box. Okay. Yeah. So this is the LED. Now, how the connections are there for LED? So I have already told you there is a current limiting resistor, and then this is anode is connected to positive terminal of the power supply and cathode is connected to negative of the power supply. If I am doing these connections, this LED will glow. Okay, if I'm doing this connections, this LED will glow. Now if I want to add a switch, yes, of course I can add here. Okay, now if now this is off switch or on switch, so this is off switch. Okay, so I can push it down and make it on. So whenever I will make the switch on, LED will glow. Whenever I will make the switch off, LED will not glow, right? So like this we are doing the connections. Why I'm showing you the LED connections, because you will find means what I will do, we will take the outputs and we will connect LED to the output so that we can check the possibilities that whether I'm getting the output or not. Okay, so let us do it in a very simple way, that this is my, yes. So what I will do, I will use a breadboard first of all. Well, I'm using a breadboard. So what I'm doing, I will rotate the breadboard according to convenience. And I'm first of all we will just test XOR gate IC. Okay. So now you want XOR gate IC. 7486 is the number, and you can just connect it. I'm connecting it here, right? So this is your XOR gate IC. So for every IC, we need VCC and ground. So we need a power supply. So I'm giving a power supply here, and it is of 5 volts, right? Now, just check it out. What I'm doing, I'm connecting the power supply here. Okay, let me connect it with red color, and this 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 power supply is connected here, so these are horizontally shorted, so you can see green color highlight, right? So this all points got the power supply, right? Now same thing I'm just extending same thing. Okay, and I'm connecting one more wire from here to here. Okay, so I think that you should understand this, that this line, this all the dots are connected to power supply 5 volts, as well as these dots are connected to 5 volts, right? Similarly, what I will do, I will just do another thing, that I will just connect the ground connection here, and by using black color, and similarly this is connected somewhere here. Okay, sorry, I will use this minus terminal. Okay, So इसका मतलब ये है कि this all the dots, right, these are connected to negative point of the power supply, that is you can consider it as ground. Okay, so this minus complete line is your ground connection, plus is your plus VCC, right? I'm configuring like that. Okay, now each and every each and every IC will have a power supply. So this is your power pin, so power pin is connected to plus VCC. I will use some red color, and this ground is connected to ground, so here I'm just connecting it to, this is your ground pin. Okay, so I guess all of you understood how to apply the power and ground connection to your IC. Yes, no? I can see
Yes,
in the
sir.
chats.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
okay, great. So this is like how I'm just connecting the power supply. Okay. Now, very important thing that yes, I want to give the input. So how I will give the input? So I will just use again a breadboard. Let us say that I'm using this breadboard, right? Now, just see how I'm giving the power supply. So I'm connecting this line here. I'm connecting this line here, and again I'm connecting it by using red color. So this complete green dots, right, these are connected to plus VCC. Is it correct? I guess yes, you can correlate to that. Okay, and then what I will do, I want a switch. Okay, I want a switch. So just what we will do, okay, I want a switch. So maybe I need, okay, I need this switch, right? This switch I will take for your, okay, and now this switch is connected. This switch is connected here. So let me connect. Just 1 second, okay. So let me connect. Uh, see, this I am connecting to one part of the switch. Okay, so I may use here maybe yellow color. Okay, and then this power supply I'm giving to second switch, maybe this is green color. Okay, so why let us say that this is input A, 1A is connected to this plus VCC, and this is 2A is connected to again plus VCC, right? Now I want to give the input. So what I will do, uh, I want to also visualize whether I'm giving the input or not. Okay. So if I'm visualizing how I'm giving the input, I should have some indicator with that. Okay. So what kind of indicator I will be using? So I will be using an LED. Okay. So how I will be using the LED? What I will do, I will just put an LED here as a LED. I have this LED. So let me put the LED here. Okay, and now now this LED, okay, this LED, I am, this is anode, so anode is connected to positive supply, right? So this is your anode, is it correct? Yes. So anode is connected to positive supply. So and also we need to have a resistor. Okay? I'm connecting a resistor, right? See, anode is connected to resistor, and resistor this end of the resistor I am connecting it to switch A with again yellow color. Okay, and then इसका मतलब ये है, समझिए आप. ओके, इसका मतलब ये है कि पावर जो है वो यहाँ से आ रहा है, ये स्विच में से यहाँ पर जा रहा है, इसमें से रजिस्टर में जा रहा है, रजिस्टर में से एलईडी में जा रहा है, और एलईडी का कैथोड कहाँ पर कनेक्ट होना चाहिए? ग्राउंड को, राइट? सो एलईडी का कैथोड, राइट, एलईडी का कैथोड जो है वो मैं कनेक्ट कर रहा हूँ ग्राउंड को. ओके, सो अगेन आई विल टेक this thing and I'm connecting it to ground. So you can just see ground is my negate. This is your ground, okay, and I am representing it by black color, okay. मतलब इसका मतलब ये है कि whenever I am starting simulation, I have started simulation, right? So this LED is on or off, it is off, right? So see, this switch is off, that's why LED is off. So whenever I am making this switch on, at that time you will get the LED on, okay. So this indicates that I am giving the input, right? 1 0 0 means off LED, 1 means on LED, okay. This is only for my reference purpose, okay. Now what I will do, I want one more LED, because we have how many inputs we have? We have A, B, C. So for three inputs, I have three LEDs, right? So again, what I will do, again I will take LED. LED. So let me do it simple for you, right? Let us say that yellow LED for yellow color, then another will be green LED. So I will take another LED, I will just put it here, and I will say that its color is green. And one more LED I will take, I will put it here, and let me say that its color is orange, okay. So yes, now again similar type of connections we will be doing, similar types of connections we will be doing. Resistor, right? So we have resistor, we are connecting the resistor to this anode, and one more resistor we will take, we will connect it to anode, okay. Now this resistor is connected to anode, and then this cathode is connected to ground. So can I say this complete green color is ground, because this is connected to this point, and these are horizontally shorted, so these are connected to ground. So this must be connected with ground, so I am just connecting it here. And this again, it must be connected with ground, so I'm connecting it here, okay. And then I need to give a power supply. So this green is connected to second, so second, this I will be connecting it to this, right? And this will be a green color, getting? So see, power supply coming from green to, from here it will go to resistor, from resistor to anode, anode to cathode, cathode to ground, and then like this the circuit will complete. And similarly, if I want to connect a third, what we can say, if I want to connect third input, so I will use orange color, okay. And sorry for that, this was your green color, and for orange I will use orange line, not an issue. And this is connected to this point, so this is your orange. And इसका जो कैथोड है ये आपको कनेक्ट करना था ना ग्राउंड पे, तो ये मैंने यहाँ से कर दिया, okay, yes, so it is there, right? Now let us check whether the three inputs whichever I am giving, that is correct, working or not. So pin number 1, yes, switch number 1 LED on off हो रहा है, सेकंड ऑन ऑफ हो रहा है, थर्ड भी आपका ऑन ऑफ हो रहा है, राइट? तो मैंने इंडिकेटर्स भी यूज कर लिए है, करेक्ट, ओके। नाउ output side maybe मुझे at the output side also I want to see the I want to get the output, so again I will use the indicator, so maybe I will use breadboard, इस प्रकार का मिनी ब्रेडबोर्ड ही यूज कर लेंगे हम लोग, ओके। एंड नाउ you can just check the output here. So देखिए अभी इनपुट जो इसके अंदर ये कौन सा गेट है, XOR गेट है। सो XOR गेट let me just, okay, let me just draw it here, and let me just tell that yes, your XOR gate is like this, right? So this, let us say this yellow and green is your input, and let us say y is your output, okay. So iske possible combination 0 0 0 1 1 0 and 1 1, right? So this is 1. So what is the output of XOR gate? Output of XOR gate is 0 1 1 0, right? So this table we need to verify. So you can just see here, and we can see this is your input A, right? So input A, I'm just giving this input A, that is I'm connecting from here, okay. So sorry, so this is your input, this is A, right? Let us say this is yellow, okay. And then second is your green color, okay. For this I am directly connecting here, okay. for understanding purpose. Okay, and then output, you know, this is input 1a, input 1b, right? पहले गेट का a input, पहले गेट का b input, और this is output, right? पहले गेट का output, right? तो पहले गेट का output भी हमें देखना है whether it is high or low. Okay, so यहाँ पर output क्या आएगा? High रहेगा तो plus VCC आएगा. So you know this output I need to connect it to somewhere here, right? That is, let us say that this is red in color. Okay, output थोड़ा दूसरा color ले लेंगे हम लोग, maybe blue color, right? And then you know, if I want to see the output, I need to use LED. So if I'm using here LED, right? If I'm using here LED, I need to connect it to anode, but through a resistor. Okay, so I'm using here, this output is going through the resistor to anode, and then this cathode, you must say that it should be connected to the ground. So this is your ground terminal. Okay, so like this is very simple circuit for your output. Okay, now let me start simulating it. And yes, connections बाद में हम proper करेंगे, मतलब ground को black कर देंगे. But yes, now let me start simulating. Now 0 0, so output is also 0, isn't it? Now let us check this condition. 0 1 means yellow is 0 and green is 1. So I will just make click this. So green is 1. So what happened here? The problem is that IC is bursted, so there may be some improper connections. Okay, so I'm just finding out what is the wrong thing. So I'll stopping the simulation. So this is your output. Output is connected to anode and it is connected to ground. So this path is also correct. Let me check. This is ground. This is ground. This is power, that is plus VCC. This is also fine. This input is given and output is also given here. Input, output 1. Just a second, okay? Let me. What is brown, brown, and maybe brown, brown, yellow, brown, brown, sorry, red, red, brown. What is the resistor value of red, red, brown? Yes, 2.2 kilo. 2 point brown. Uh, mm, just I will make it as default 1 kilo ohms. Uh, Okay, can anyone find out where
220 ohm.
is there any connection which is remaining or
Sir,
yes?
input 2B will be at pin number 5.
Huh?
Input 2B, you are
Input?
connected it to 1B.
What input?
Input 2B,
2B,
sorry 2A.
2A, huh?
It should be connected to pin number 4.
No.
Input 2A.
See, we want output, right? Okay, let me. So there is problem in the input, right?
Yes.
Or change the resistance values.
Change the resistance value. What will happen from that?
No, sir. It is you check at pin number from input 2A. ग्रीन वायर है ना 2A की
No, no,
स्विच के
no.
पास
Huh?
स्विच के पास वो 2A है ना.
Huh?
हाँ तो 2A तो फोर्थ नंबर पिन है ना.
No, that is also correct.
Sir, I am getting the output, sir.
You are getting the output.
Even I'm
Yes, sir.
getting.
Sir,
There is
just
some
check that
problem.
yellow line, sir.
Hello.
Sir, just check that yellow
So
line.
I think the direct connection.
Hello.
Yes, sir.
Hmm. Are you getting the output for this? Just try it out once.
तो वो इनपुट ए का वो जो लाइन है ना वो एक बार चेक कर लो सर.
Input A ka line is fine, right? Let me again. So this is your directly I'm connecting. Okay, so still it is getting busted.
सर इनपुट 2A का शायद.
No, 2A that is also fine.
सर आपने वो 1B को कनेक्ट किया है.
So, but
हाँ तो देखिए गेट नंबर 1 का इनपुट, गेट नंबर 1 का बी इनपुट एंड दिस इज गेट नंबर 1 का आउटपुट. 4 गेट होते हैं ना आईसी में. You can just check it out if you want. IC74, IC7486, right? Pin diagram. So you can just check it out. So this is, see, this is the IC, and we can get gate number 1 ka input, gate number 1 ka second input, and output of gate number 1. So it's like that. A1, B1, Y1, A2, B2, Y2. So it's correct. Connections are correct, right? This, this is also correct. Yes. Plus VCC, this is also correct.
so haven't you connected the resistor on the other mini board?
Resistor is connected, right? Resistor is
No,
connected.
the second mini board. Yeah.
that will be connected, right? But okay, this is connected to output. This I can connect it to output. So let me give the output. So that is not a problem, okay? Because my IC is getting busted. So there is a minor mistake, right? Uh, 7486, that is also fine. Okay, let me delete it. Let me rejoin it. Great. Okay. So problem is sorted out. ये जो line था ना red वाला, that was shorted with ground. So okay. So please make proper connections. That's what I can say. Okay. So now I will start simulating, and then we will check this second possibility. A is 0 and B is 1. So this is yellow is 0, green is 1, and I'm getting 1 at output, right? And if I will make both ones, then output should be 0. So I'm making both 1. So yellow and green both are 1. So that's why this output is 0. Is it correct? Right? If any one of them is 1, then output is 1. Is it correct? So like this, I have verified simply. I have verified this OR gate. Any problem in this? I guess no problem here. Yes. Okay. And
Yes, sir.
I will stop simulation and I will move towards implementation of our implementation of uh, implementation of this above circuit, right? So I want AB, I want AC, I want right. So first of all, I will implement sum. So for sum we have AX or B, and then I want one more gate, right? So from where I can take one more gate? So I will take, सुनिए, पहले का जो output है A X और B, वो दूसरे gate के input को जा रहा है, right? So here what I am doing, I will just remove this thing, and I am giving the output of first gate as a input of second gate, right? So I'm just connecting here with this line, and then the second input is nothing but your third input, right? So from here I'm giving this second जो गेट है आईसी में, उसका जो सेकंड इनपुट है, that is your C. So C is in orange color. Yes. So I've given this third input, and now the second gate का जो output है, right? So this is your first gate, right? So if I want to write down the pin numbers, then this is pin number here, pin number 1, pin number 2, and this is pin number 3, which is connected to pin number 4, and this is pin number 5, and here pin number 6 I am getting the sum. What at pin number 6 I am getting the sum. So here same thing I am doing, right? So this is pin number 1 2 3. तो पिन नंबर 1 2 ए बी, वाई पे क्या आ रहा है ए एक्स और बी, तो ये जो 3 है ये कनेक्ट कर रहा हूँ 4 से, 5 को दे रहा हूँ सी, तो आउटपुट 6 में आ रहा है ए एक्स और बी एक्स और सी. तो आपको ये समझ में आ रहा होगा शायद. यस नो व्हाट आई एम डूइंग? यस. तो देखिए,
Yes, sir.
हाँ, इनपुट ए और बी, एंड दिस इज आउटपुट. आउटपुट इज कनेक्टेड टू दूसरे गेट के इनपुट. दूसरे गेट का सेकंड इनपुट है आपका सी, एंड देन this is your output. So this I am just trying to fetch the output from here, and I am giving it here, right? Let me give it by some pink color. Okay. And now here I will get what? Here I will get sum, right? Here I am getting the sum, so we can obviously verify the truth table of sum, right? So we can just verify the truth table. So see, I'm starting the simulation, and then 0 0 0 sum is 0. Okay, 0 0 1 sum is 1, right? Then 0 1 1 sum is 0, correct? And 1 1 1 sum is 1. बराबर है? Correct?
Yes,
sir.
sir.
So you can just verify all the combinations which we have seen here, right? We need to see that if this combination 001, then sum should be 1. If it is 011, then sum should be 0. If it is 111, sum should be 1. So ये चार 1 ये corresponding inputs को आ रहा है कि नहीं वो देखना है, right? So this is implementation of sum. Is it simple? So I guess this is very simple. Now we will go towards implementation of carry. So for carry, what we want AB, BC, AC means what AND gate we want, right? So if we want AND gate, I will just stop simulation and I will just see AND gate IC and gate. So IC for AND gate is your 7408. So I will take this IC and I will just rotate it and I'm connecting this IC here. Okay. Whenever I'm connecting the IC, I need to give the power supply as well as I need to connect. So power supply, let me give it by red color, and this is your ground pin. So this I'm connecting it with black color, and then you want AB. So from where you will take A and B. So from here, this is yellow color. This is your A, correct? Just check it out. Yes, input A with yellow color, then B with green color. So this is your B. So this output is output 1. So this is your AB. You got this AB. Similarly, now you want to give BC. So ये जो यहाँ का input 2 है, that is connected to B. So this is B again. So here I am giving B, and this is your input 2. So this is connected to C. So this is orange, right? So AB हो गया. This is BC, and similarly AC. AC is given to, let us suppose, this is output 3. So let us suppose input gate input 3A and 3B. So यहाँ पर मुझे क्या देना है? AC. So from here I want to give AC. So I will just take A from here and I will try to give it here, right? So this is input 3. So this is A. एंड ये एंड गेट है ना, एंड गेट के अंदर दूसरा जो इनपुट है वो कौन सा है आपका? सी. सो दिस ऑरेंज कलर इज सी. सो आई एम गिविंग हियर AC, राइट? सो यहाँ पर AB है तो आउटपुट में क्या आएगा? AB. BC है तो आउटपुट में क्या आएगा? BC. एंड AC है इनपुट में तो आउटपुट में क्या आ रहा है? AC, राइट? सो AB प्लस AC मुझे करना है. AB प्लस प्लस मतलब कौन सा गेट चाहिए बोलिए? सो यहाँ पर मुझे AB आया, BC आया, AC आया. AB प्लस BC चाहिए तो कौन सा गेट चाहिए?
OR gate.
OR gate, right? So
OR
for
gate.
OR gate, here I will just type OR gate, right? So 7432 is the OR gate IC. So I will just put it here and I will rotate it. I'll make sure that the connections are proper. And then I'm connecting, obviously whenever you are connecting the IC, you must connect it to ground. You must connect it to ground, and you must give a power supply to the IC also. So I've given the power supply here. And then this is आपको चाहिए AB plus AC. तो AB यहाँ से आ रहा है आपका. So I'm directly connecting from here to here AB with some very different color. Maybe we can have brown color. overlap दिख रहा है. पर्पल कलर. ओके. सो जो पर्पल कलर वाला लाइन है वो है आपका AB. उसके बाद में यहाँ पर B है, यहाँ पर C है, राइट? B एंड C. सो ये जो आउटपुट है ये कौन सा है आपका? BC, राइट? सो दिस इज योर BC. So maybe this is again some Turkish color. So this is AB and BC. So this is input A is AB, input B is BC. So output में क्या आ रहा है आपका? AB plus BC. Okay. So सुनिए, आपको AB प्लस BC मिल गया. नाउ अगेन यू वांट वन OR गेट. तो आप उसी IC में का, ये जो IC है इसमें का दूसरा OR गेट यूज कीजिए. दूसरा OR गेट जो है उसको इनपुट क्या है? पहले का आउटपुट. सो पहले का आउटपुट जो है वो दूसरे का इनपुट बन गया यहाँ पर. ओके. पहले का जो आउटपुट था वो दूसरे का इनपुट बन गया. और फिर दूसरा इनपुट क्या है इसका? दूसरा इनपुट ये है कि दूसरा इनपुट है इसका एसी, एसी कहाँ पर है आपके सर्किट में? आपके सर्किट में एसी मिल रहा था मुझे, ये ए है ये सी है, तो आउटपुट में मुझे आ रहा है ए इंटू सी, ए एंड सी. तो दिस आई एम गिविंग from here. I am just taking the line and I am giving it to maybe here, okay, because this is input number 2. So let me give it here, okay, with some color, maybe again some pink color, okay. And then output, what I'm getting at the output. So here you can see I have AB plus BC, and then I have done AB plus BC plus this AC. So output you will get, and that output is nothing but output of second OR gate. So here this is your output of second OR gate. This is nothing but your second output, and here maybe I will connect it here with some color. Maybe I will put some LED, okay, for representing the output. So LED. So here I am connecting one more LED. And what color we should take of this LED? Maybe which color? White color is remaining, right? So ये जो line है इसको हम कुछ gray बोल देते हैं, okay? And then this output is going to LED through a current limiting resistor. Maybe I will put a resistor here, and this is connected, cathode is connected to, obviously this should be connected to ground. So this I am connecting it to ground, okay. So this LED, right, जो LED है ये क्या इंडिकेट कर रहा है आपका? कैरी. और दूसरा जो LED था ये क्या रिप्रेजेंट कर रहा था? सम. तो इसको मैं कैरी वाला LED बोल देता हूँ, right? White color is the carry LED and red color is nothing but your sum LED, okay. Now you can just take all the combinations, okay. Let me start simulating it. So 0 plus 0 plus 0, sum is 0, carry is 0, right? 0 0 1, sum is 1, carry is 0, right? Now 0 plus 1 plus 1, right? 0 plus 1 plus 1, carry should be 1, sum should be 0. So I'm not getting the carry. Let me check why I'm not getting the carry. So here, output 3. So let me check the carry, right? So carry 1 1 1. So carry should be 1. Okay, great. So it's correct, right? So 1 1 0 1 1 0. सुनिए 1 0 0, sum is 1, carry is 0, right? Now tell me 1 1 1 1 0, sum should be 0, carry should be 1.
0
हाँ.
1.
So देखिए रेड 0 होना चाहिए and white वाला 1 होना चाहिए. So 1 1 0, red 0, white 1, correct? Can you see glowing?
Yes, sir.
Okay.
Yes,
And
sir.
when I will do 1 1 1, so at that time
Both
both the
both
lines
will
should be
glow.
glowing. So output should be 1, means carry be 1, sum be 1. So this is exact implementation of the circuit, right? What we have seen here, okay. And in our write-up, if we go to the write-up, the same thing is given, right? Some basic gates and its explanation, then pin diagram, and what you need to do, you need to implement the full adder, okay. So I have implemented by using one circuit. So this you will try. After that, this is another circuit. So this also you have to try. This is your implementation of full adder by using two half adders, okay. And then you have to write the conclusions, okay. So any problem in this? I guess there are no problems. Yes, no?
No, sir.
No problem, sir.